In this one here, there is a slant row, and the mass is uniformly distributed. So the mass center point G should be the middle point of this slant row. The rotation center is here. So this means if we don't have this code, then this slant row is not balanced. So initially, it was at rest because we have this code. If we cut this code, what will happen? The slant row will lose its balance. Then rotation will happen about this fixed axis 0.0. Okay. So this problem is actually similar as the first example. The only difference is in that problem, it's an unbalanced flywheel, but in this one here, it's a slant row. Okay, so this is rotation about fixed axis 0 point. So in this one here, I can draw my free body diagram. And kinetic diagram. Okay. And for this problem, I will also use normal tangential coordinate system. Okay. And this time, I define normal component, normal direction, positive direction is to right side. And for tangential direction, downward is still the positive direction. Okay, so in this one here, at this reaction axis 0 point, we have O, Y, sorry, not Y, it should be OT. I assume this one is upward. Sorry, this is not assumed. This is the actual direction. And by observation, you know OT must be upward. I have ON. I assume it's positive. And here I have W. Gravitational force. And then in the kinetic diagram, I have I, G, alpha. Alpha is counterclockwise positive, assume. And I have M, A, G, N. And direction from from G to O. And also I have MAGT. Again, MAGT, AGT is direction, is related to alpha. If you indicate alpha counterclockwise, then in this case here, AT, its direction must be downward. Okay. Any questions? Now, let's have a look. Solution. Again, we firstly can define this problem, and again, at this instant, when the code is cut, omega at this instant must be 0. Okay. And we have already got our diagram. And again, in my following calculation, to deal with this unknown OT, I still assume it's downward positive. in my following calculation. And to remind myself, I use red color dashed line to remind myself this is assumed direction for OT. Okay. Assume the direction in the following calculation. Okay, so the calculation won't be very different from before because we are using normal tangential coordinate system. So for translational component, it will be about normal and tangential direction. For the rotational component, we still use point O for our calculation. Okay, again, for n direction, normal direction, it should be 0 because omega at this moment is 0. Along tangential direction, we have OT and W. Okay, we assume OT positive and W downward according to this coordinate the system. It should be positive. Okay, it should be positive. So we have our second equation. In this one here, we have OT and alpha. Here for AGT, AGT magnitude, alpha times the distance from G to O. For AGT, as mentioned, because we already assumed alpha counterclockwise, then AGT must be downward. AGT downward according to this coordinate system should be positive. And then for the third equation, for the rotational component, for summation of external forces, the summation of the moment of external forces about point O, you can see in this diagram here, only W should be counted, okay, because the moment arm from W to O is not 0. And it should be counterclockwise, and also you can see it should be positive. Okay. On the right side, we have IG alpha and also kinetic moment generated by AGT. For AGN, the moment R again is 0. Okay, now we have equation 2 and equation 3 for our calculation, and we can solve alpha positive 16.4 positive. So that means the indicated or assumed direction of alpha is correct. For OT is negative. What does this mean? This means OT should be upward negative instead of the assumed positive downward. Okay? So that's the solution for this third example problem. Any questions? Any questions for the diagram and the calculation process? Any questions? Okay, if no questions, I think today we can conclude our lecture early. Just a remind, the quiz 2 will be due at the end of this week. So please remember to complete quiz 2 as early as possible. Okay. Thank you. Oh, I think, yeah. Okay, thank you. Thank you for your attention.